Here we will write the C program to convert binary to decimal number. This logic is applicable for the positive integers. Let us see the algorithm to convert binary to decimal. As we know, decimal is 10 digits made of 0, 1, 2, 3 till 9, and binary is only 2 digits 0 and 1. With that in the background, let us take an example 1010. For this binary, we will convert it into decimal. To convert that into decimal, first we have to take the unit position, that is 0th position from the right side, and multiply it by 2 to the power of the position of that digit. Here 0 multiplied by 2 to the power of 0, which is the position, unit position of the digit. To that we have to add the next number, that is 10th position from the right side for the binary digit. Here it is 1, which should be multiplied by 2 to the power of 1, because its position from the right side is 10th position. If we consider unit as 0, 10th position is 1, hence 2 to the power of 1. We have to continue this process until we have considered all the digits of the binary. If you see, 2 to the power is getting incremented starting from 0. 0 represents the position, 0th position of the binary digit starting from the right side. Here our binary digit is 4 digit, so maximum 2 to the power of 3, that is 1000th position, is what we are getting it. If we see in detail, 0 multiplied by 2 to the power of 0 is equal to 0, but 2 to the power of 0 is equal to 1. To emphasize this point, I am expanding it as 0 multiplied by 1. Please remember, 2 to the power of 0 is 1, it is not 0. And similarly, in the next 10th position is getting expanded is 1 multiplied by 2 power of 1 is equal to 1 multiplied by 2, as 2 power of 1 is 2. And the 100th position becomes 0 multiplied by 2 power of 2 is 4. So 0 is multiplied by 4 here. And the 4th digit is again 1 at the 1000th position, that is 1 multiplied by 2 power of 3 is 2 into 2 into 2. 2 multiplied by 3 2's is equal to 8. So we have expanded in this step 2 to the power of the integers. That is what we did in this step. So the calculated portion is 0 into 1 is 0, plus 1 into 2 is 2, plus 0 into 4 is 0, and again 1 into 8 is 8, which is equal to 2 plus 8 equal to 10. So the binary 1010, when it converts to decimal, is 10. As we know, 1010 is equal to 10 in decimal. So let us take one more example, and we will consider the binary value of all 4 ones here. We know the equivalent for 4 ones in binary is 15 in decimal. We will expand quickly. The first one I have taken here is the from the 0th position from right side of the binary digit. So 1 multiplied by 2 power of 0. Then again 1, which is 10th position, multiplied by 2 power of 1, because it's in the 10th position of the binary digit starting from right. If we expand this completely, third one is 1 into 2 power of 2 plus 1 into 2 power of 3. We have only 4 digits. So the corresponding multiplied value is what I am writing here. You can see 1 multiplied by 2 power of 0 is equal to 1. As we know, 2 power of 0 is 1. 1 multiplied by 1 is 1. And so on. So 1 plus 2 plus 4 plus 8 is the resultant, which gives us 15. Hence, the decimal equivalent of the binary 4 ones is 15. So the logic involved is take from the rightmost end the digits from the binary and multiply it by 2 to the power of the position of the digit we have taken. And remember, 2 power of 0 is 1. So this is the logic that we will apply in our C program to get the decimal equivalent of the binary. Let us go for our coding portion and declare the variables. Binary number is a variable for which we will get the input from the user. It is for this binary number we have to find the equivalent decimal number. So let us also declare a variable decimal number and initialize it to 0. We will get the binary number for which the decimal conversion has to be made from the user using scanf statement. But we have to consider while providing an input, as it is a binary number, from the keyboard we will give only zeros and ones. If we recollect, binary number is the sequence of zeros and 1 only. So we will ensure when taking the input from the user, the input is only a sequence of 0 and 1s. Now let us start a while loop to check if the entered binary value is not equal to 0. So if it is equal to 0, we will come out of this while loop. As a first one, let us get the rightmost digit of the binary number. We can get this by modulus of 10 operation. So let us have a variable called remainder, and the value to the remainder is modulus of 10 to the binary number. So as we recollect, we should first get the rightmost digit of the binary number, which is nothing but the unit position. So to get that unit position, we are doing modulus of 10. Let us see if we are getting the digits in the right order. So let me have a printf statement at this place to see what is the remainder. As it is a while loop, it will get executed until binary value is equal to 0. I am also adding the step number inside the printf statement. So To know the steps, let us introduce one more variable I, and we have to declare a reminder and I. Let me initialize I to 0 so that our loop count will start from 0. So coming back to the while loop, I am going to increment the I so that the step is counted, and we can exit from the while loop only when the binary number equal to 0. So I'll do divided by 10 operation to the binary number. So at one stage the binary number will be 0, which will satisfy the condition to exit our while loop. For better clarity, let us print each step reminder value in new line. Here inside the while loop, I have not yet done the conversion for decimal. I am only trying to print the reminder value at each steps. So let me provide the input 1010 as the binary. So reminder at step 0 is 0, which is the unit digit. As we have seen in our design, first we have to get the unit positions. So the second at step 1 is the 10th position, and at step 2 we are getting the 100th position, and step 3 we are getting the 1000th position. So as of now, till this we have ensured that the remainder is coming in the desired way, starting from the rightmost digits of the binary value. Now we will proceed to do our conversions. We got our remainder. As we recollect, the digits, rightmost digit is what is present in the remainder. So that should be multiplied by 2 to the power of position. If we recollect, I variable we have initialized to 0. So at first instance it is having the position as 0. So I am using I as such for this, and POW is a library built-in function which calculates 2 to the power of I. So decimal number is calculated by rightmost digit, which is stored in the remainder, multiplied by 2 to the power of position of that digit, starting from 0. So power POW is a built-in function, hence I will include its corresponding library file. It is there in math.h. So now we have included the math.h file, which has the functionality to provide power to our requirement. Now we will go and print our converted decimal value. Let us compile this code. It is compiled successfully. Once again we will provide 1010 as the input for which decimal has to be calculated, and the decimal value is 10 as desired. If we go back and then have a closer look at our while loop, while loop is executed until the binary number is not equal to 0. When it is 0, it will come out of the while loop. As a first step, we are trying to get the rightmost digit of the binary number. This is achieved by doing modulus of 10 operations. The rightmost digit we get is getting multiplied by 2 to the power of position of that digit we have in remainder starting from 0, and that is added to the decimal number. As the position has to be incremented, we increment I. We have incremented I, and also we have to right shift the digit. This is achieved by dividing binary number by 10 so that the digits are shifted to right by one position. At the next stage, we will have the binary number shifted by right by one position. Again, on executing this code, I'll provide 4 ones and the equivalent decimal is 15. So it is correctly converting the binary to decimal. Let me also provide some little bigger digits of binary 1010, 1111, and the equivalent decimal value is 175. So our program, C program